Welcome to this session of the cloud computing course. In the last class, we saw a little bit about how networking works. We also saw the internet and the TCP/IP suite, and then we discussed about the various communication. Since cloud is a distributed environment and all the processes are expected to be in different geographical locations, therefore, communication among the processes is a very important aspect, and we started discussing that in the last class. This class we are going to see how the communication is going to be reliable, because the communication is completely dependent on the networking, and we have already said that networking is extremely unreliable. Therefore, in spite of the unreliability, how best to use communication in a distributed environment to make it reliable is the topic that we are going to discuss today. So, in this we will see the group communication. First we will see the reliable communication, and then we will discuss the group communication. So, what is a reliable communication? A reliable communication is a communication service that is able to mask some of the failures that may be injected due to the unreliability of the channel. So, therefore, what we are going to discuss today is the fact that our underlying assumption is going to be that the channel is unreliable, channel meaning the networking, the internet is unreliable, and how we still provide a reliable communication. So, to define a reliable communication, we have three mechanisms that we have to discuss. We have to discuss what is validity, we have to discuss what is integrity, and we have to discuss what is agreement. So, validity is when a message sent by a sender is eventually received by the receiver, we call it a valid communication, which automatically implies that it is not necessarily that a message sent will be a message received, but if a message sent is always a message received, we call it a valid communication. The next is the integrity. Integrity has two assurances. The first one is that the message received is identical to the one that is sent, and the second one is that no messages should be delivered twice. So, if one message has been delivered to one system, it must be ensured that the same message is not delivered one more time. Here we follow what is called the at most once protocol. In a distributed environment, it is possible to have exactly once protocol, which means that a message sent will be received exactly once. It is also possible to have at least once protocol, where we say that it may be received once or it may not be received at all. In at most once, we say that maximum one time it will be received. It will never be received more than once. And then finally, we see the agreement part of the reliable communication, where we see that the agreement is that if a message is sent and is delivered to one of the processes in a group, then it will be delivered to all the processes in a group. So, this is applicable only for a group communication. The other two, earlier two, are applicable for both single communication and group communication. So, what is the problem of validity? The communication using a message and over a network causes the problem of validity. So, we said that validity is that the message, if it is sent by the sender, will be received by the receiver. Why this is not guaranteed in a distributed environment like cloud? Because we are sending message over a network and network may fail, network may drop a packet, network may be unable to deliver the packet, and therefore, a message sent may not necessarily be message received. What is the problem of integrity? There are two independent sources from which integrity threats come. One is that the protocol many times it retransmits a message, but when it is received it should reject the duplicate message, so that there should not be any duplication. So, if I send a message, as we have discussed already in TCP, what happens in a TCP IP protocol, the message is sent, and if the message is not received within a certain time, the message is retransmitted again. If we do this, then if the earlier message also is received and the later message is also received by the receiver, then we have a problem of duplicacy, that two messages are received. And the other problem of integrity is that there may be malicious attackers on the way. When I sent a message, that it may be intercepted by an attacker and it may be changed or made incorrect by the attacker. So, these are the two problems that our communication mechanism has to ensure that should not happen. The next is the agreement problem. Essentially, in a group, the cooperative agreement is very difficult. So, what do we mean by cooperative agreement? Typically in a group, we expect that some work will be done either by all the members or by no member at all. So, if we take an example of a database, then assume that there are multiple copies of the database replicated in various data centers, and if one copy is updated by one user, then the system, by the guarantee of agreement, has to ensure that all the copies are also updated. If that, now why that should not happen or that may not happen? It may not happen in case if there is a network failure or if there is a network partition due to failure, then what may happen is some processes or some data centers get updated with the new data, but some data centers may not be able to agree to update. So, that is the problem of agreement. Now, why we are discussing these three conditions for reliable communication is because in any cloud environment, whenever we offer communication, we have to understand that the communication can either be reliable or unreliable, and based on the user's requirement, we have to ensure that we provide the kind of communication that is required by the user. If the user wants a reliable communication, then it is the guarantee of the cloud service provider that all communication that happens between processes run by the user has to have both all the three parts of reliability, validity, integrity and agreement. Now, let us see what are the types of groups. First types are closed group and open group. In a closed group, we have a system where all the processes inside the group, this circle you see are the processes inside the group, they can communicate with each other, but any process that is outside the group is unable to communicate with the inside processes. Whereas in an open group, the processes within the group are able to communicate with each other freely, and also any process that is lying outside is also able to send messages to to one or more participants of the group. The next is the type of overlapping and non-overlapping group. In overlapping group, we have the entities, which are the processes of course, are member of multiple groups. Now, in a cloud environment, most of the groups are overlapping groups, because a process or a node should not be dedicated to one user and one specific work of the user. So, therefore, the processes will be participating in multiple groups and they will be doing multiple activities. However, in a non-overlapping group, we have members dedicated to one specific group. This does not mean that the process cannot ever participate in other groups. In a non-overlapping kind of environment, what is guaranteed is, while the process is part of one group, it is not going to participate in another group. So, at any point in time, one group membership is to be had by any single process. So, we see closed group, open group, then overlapping group and non-overlapping group. The other categories are synchronous group and asynchronous group. In a synchronous group, the boundaries of all times are specified or can be calculated well in advance. What are the boundaries that we need? We need boundaries for a message to be generated. We need boundaries for a message to be sent. We need boundaries for a message to be received. And also we need boundaries for any processing that happens in the environment. So, in a synchronous group, nothing should be unbounded. All values we should be able to define right at the beginning and then continue. Whereas, in an asynchronous system, the boundaries are not well defined. The systems may take more time or less time, and these are quite acceptable in an asynchronous group. For all practical purposes, all our cloud environment do come under asynchronous group, because the cloud environment is a heterogeneous environment. So, the processing powers of various systems are different. So, it is very difficult, almost impossible to predefine that a specific process is going to take, specific processing is going to take this amount of time. That is one problem. Then communication in cloud is dependent on the internet, which we have established that is unreliable. So, therefore, all communications are unbounded. We cannot put a bound saying that a communication will be completed starting at this specific time, will be completed within this time. So, typically the cloud environment is a asynchronous environment. However, there may be some situation very specific, very required situation where we may need to discuss synchronous group also. So, both the synchronous systems and the asynchronous systems are required in a cloud environment. So, now we will see the three mechanisms used for multicasting, group communication, multicasting, broadcasting and unicasting. So, first we will see what is unicasting. In unicasting, one sender and one receiver will send a message one to one. So, if there are more than one receivers, then for every receiver separate one unicasting will be executed, and therefore, all the group members will be receiving one separate unicast. Whereas, in a multicast, only those specific processes will be sent the messages, and all these specific processes will receive the message. So, these are the two mechanisms, unicast versus multicast. The cost of unicasting is very high, that goes without saying, because every member of the receiving group has to be sent a separate unicast. So, the creation of the message and then sending of the message has to be done separately for each receiving entities. Whereas, in multicasting, I create one message and send it to all the group. The next one is a broadcasting. In broadcasting, each process is sending a message to all the other members of the network. So, how is this different from a multicasting? In broadcasting, all messages go to all processes irrespective of whether they are part of the group or not. So, how do I decide whether I want this message or not? Every time a message arrives, I look at the message and see whether it is meant for me or not. That means, it is meant for which group and am I part of that group. In case I am part of the group, I accept the message. In case I am not part of the group, I delete the message or drop the message. Obviously, there is a lot of network congestion that happens if we use broadcasting instead of multicasting. So, we look at multicasting and various aspects of it. Most of the network does have multicasting, and in a cloud environment, we see that most of the cloud systems and cloud based applications are using multicasting environment. We take the example of online conferencing, which is a popular example is a video conferencing. We can take the example of all the scoreboards that are maintained in a cloud based environment. We can look at the example of the storage systems or databases. We can look at the example of air traffic control, where every controller, there are many controllers, and every controller has to receive the message. So, what is defined as a multicast group? The number of processes that are present in a group and who are going to send and receive messages among them is called a multicast group. What is where each process is sending and receiving messages. A message sent by any process in the group can be or rather should be received by all the participating processes in the group, and a new process may join, and also a process may leave a group at any point in time. So, the groups are not predefined, the groups are flexible and processes are allowed to join and leave. Now, when a multicast message is sent by a process, the multicast mechanism is responsible for delivering the message correctly. There are 4 important terms in this definition that we should look at. The first one is a multicast message. This is the message sent by one of the processes in the group to the rest of the processes. The next term is a process. The process is a sender and some process is the receiver, or a group of processes are the receiver. The multicast mechanism, so there is a mechanism that exists which takes care of the sending and receiving of the messages, and perhaps the most important word is the correctly. The message should be sent correctly. So, let us look at what we mean by the word correctness. Now, the first point of correctness is that all the nodes of the group should receive the sent message. All nodes should receive the sent message. That is the first point of the point. So, let us take an example of seeing how the correctness happens in our environment. So, here is an example where P1 is a process which is trying to send a message to the rest of the group, where there are 7 members in the group. Now, when this message is sent to all the 6 members, then correctness says that all processes should receive the message, but here we see that P2, 3, 4 and 5 have received the message. What happened to the other processes? They have not received the message. So, therefore, it is not a correct communication. Why has this happened? It may have happened because of a network failure, it may have happened because of congestion and packet drop. The next point of correctness is that the complete message should be received by all these processes. Now, let us take this example, same example where we just now saw the example before, where we have this process P1 who is trying to send a 64-bit message to other processes. When it multicasts this 64-bit message, all the processes, 4 of the receiving processes have received appropriately the message 64-bit, but 2 processes P4 and P6 are receiving only 32-bit of the message. Why has this happened? M1 may be, this process message may consist of say 2 packets. One of the packets were dropped in case of P4 and P6. The third part of the correctness is that message should be delivered in order. So, let us look at this ordering. This process P1 here is multicasting 2 messages M1 and M2. So, these are the 2 messages being multicast to all the members. Now, the message M1 followed by M2 are received by the 4 processes, but these 2 processes receive M2 followed by M1, and therefore, the delivery order is not maintained. So, why this happens? There may be a routing delay for which M2 is delivered first before delivering M1. So, correctness is at these 3 points, and the guarantee is not possible because of all the network related problems. Also, guarantee is not possible because there are heterogeneity of the nodes, and the distance between the sender and all the receivers are not the same. So, therefore, the question arises, do we actually need correctness? So, it is not always necessary to have correctness in a multicast communication. There are some applications like video conferencing, where even if we have missed a few packets or some packets are delivered wrongly, it is possible for the application to still continue. However, there are some applications like a database application, where every message to the last bit has to be delivered correctly in the correct form and correct format order to all the recipients. So, if that is so, who will ensure correctness? We will see that the correctness of multicast messages are to be ensured by the cloud service provider. So, when an application is run in a cloud based environment, the user expects a certain guarantee from the service provider, and based on that actually the user would pay the amount to the service provider based on what is required and the level of difficulty of delivering that. So, therefore, if I am hosting a video conferencing kind of application in cloud, I can easily discard the requirement of having a reliable communication, and therefore, the service provider may actually not be so bothered about delivering all my packets and delivering all the packets correctly to all the members. So, what happens in this kind of an environment is when you do not receive a few packets during a video conferencing for any multimedia streaming for that matter, the picture sometimes is a little sketchy, the sound sometimes is a little not understandable completely, some words, but in real life it really does not matter, because the context of the picture and the context of the words make up for the lost words. So, therefore, I do not expect as an application user that you provide a reliable communication to me. So, therefore, I do not ask for it. On the other hand, if I am running a database service in cloud and I for the sake of security, I replicate my database servers to say 4 or 5 locations, and these locations are geographically very far apart from one another, and I make one change in one of the replicas which is nearby my location, I definitely do not expect that the change is not reflected in all the other copies of the server. For example, if I have in my account 10,000 rupees and I add 5,000 rupees to my account and I have this server in India, then if I go to another server in say South Africa and access that server, I do definitely expect that my total amount in my account should be 15,000 rupees and not 10,000 rupees. Now, if there is an error in the message being sent from India to South Africa, if the message has not been received properly, or if the message is not ordered properly, then it may so happen that my account in South Africa will show a total of amount of say 10,000 rupees or 12,000 rupees rather than 15,000 rupees. So, for such applications it is not desirable that I have an unreliable communication. So, for running such applications I would be ready to pay more to the service provider, and the service provider has to provide a proper appropriate multicast communication which will ensure that the message sent will always be received by all processes, message sent will be received properly by all processes, and if there are more than one message, then messages will be received by all processes in the correct order. So, to conclude this session today, we have discussed how the characteristics of reliable communication. We saw that there are 3 characteristics: validity, integrity and agreement. We looked at the different types of groups we saw closed group, open group, we saw non-overlapping group and overlapping group, and we saw synchronous group and asynchronous group, and we discussed that all these types of groups are very important in a cloud environment. After that, we looked at the mechanism using which communication is done in a distributed environment. We saw we can use unicasting, where one sender and one receiver are involved in that communication. We saw we can use multicasting, where one sender can send a message to a number of receivers at the same time, thereby saving a lot of cost for the operating system or the underlying network. And we saw the mechanism of broadcasting in case I need to send to more than one processes and I do not have a multicasting mechanism, then I use broadcasting mechanism in which we send it to all the nodes in the network, and only the relevant nodes are expected to retain the received message. Other nodes are expected to drop or ignore the received message. And finally, we looked at the correctness of a multicast environment, where we say that correctness has 3 parts, and all these 3 parts put together we call a multicast communication a correct communication.